page 16.
Okay, sixth grade. Yeah, I know. We'll end class with something positive, Emma. Okay, in your notes, page 16, we are going to talk about lesson 8.5 today, which is graphing linear equations in slope-intercept form. In my mind, this is the most efficient way to graph. I like it the best out of all the ways we've learned. So before we get into the warm-up here, if you did not finish your test corrections, that's going to be part of your homework tonight. If you have questions on them, I'll take care of those at the end of class. In regards to graphing, we've already learned 2 different ways to graph. What was one method we learned of how to graph a linear function? Charles, what's one way? Good, make a table. Donatus, what's the other way? I know you have. Charles is there with you too. X and Y intercepts is the second method. So those are 2 methods of how to graph a linear function. Today we're going to learn the third way. I think you guys will agree that it will be the easiest way. If not, that's okay. You have 3 methods to choose from. Charles? Yes. All right. Let's start with going over the warm-up. Okay, so number 1 on page 16. Can someone tell us their table values that they used? Alyssa, go for it. Awesome. So if you use -1, 0, and 1, you have 6, 4, and 2. Okay. Your graph is a negative linear function. If you did not use the same points or all of those points that Alyssa said and or that I have, that's okay. Just make sure your graph looks like this. Okay, second warm-up. Emma H., can you tell us the X and Y intercept? Yep. Good. So just a summary again of how we've already learned to graph. X-intercept is 2, 0. Y-intercept is 0, 4. Graph them. Again, it's a negative linear function, so it's going down from left to right. Questions on 1 or 2 on the warm-up? No? Okay. Let's move to page 17. There's that big box at the top of page 17 that says slope-intercept form of an equation. Anyone remember what M is? You should. Briar? Good. M is slope. I want you guys to circle the M, and underneath it, write down, I can move this first. Underneath slope, okay, I want you to write down rise over run. So circle the M, label it slope. Underneath it, I want you to write down rise over run. Y2 minus Y1 over X2 minus X1. And also write down rate of change. So slope is rise over run, y2 minus y1 over x2 minus x1, and it's also called the rate of change. Anyone remember what is the B called? Donatus. Good, the B is the y-intercept. I want you guys to circle the B, write down y-intercept, and write it as 0, comma B. We always write the y-intercept as an ordered pair. X is 0, and we find what, X is 0, and we find what Y is. 0, comma B, we always know that that Y-intercept is B. Another thing I want you to add to it is always the starting point on your graph. So it's always the starting point on our graph. Important thing for today's lesson is that you know slope is rise over run, and y-intercept is written as 0, comma B, and it's the starting point. All right, let's do an example. Annalise? No, x is just x. Y is just y, x is just x. No, x is just there. Yeah. The M and the B is all we're focused on right now. Okay, for it to be a linear equation, you have to have that Y and that X. Okay. So, first example, Y equals -2x plus 4. Zach, what is the Y-intercept in this one, written as an ordered pair? So tell me what the B value is in this equation. So what's b? Y equals mx plus b. Good. B is 4. Matt, how do we write that as an ordered pair? B is 4. Good. 0, comma 4. The b is 4. It's always y equals mx plus b. That's our starting point, guys. This is always b. Okay, so when you graph that, we're over 0, up 4. There's our y-intercept. Always start with graphing that first. Slope is always m. It is also the rise over run. Doug, what's the slope in this equation? Over what? -2 over 1. So, Charles, the -2, do we go up or down? Good. The run, Sean, do we go right or left? Good, that's okay. So the rise is negative, so we're going to go down 2 to the right 1, down 2 to the right 1. So starting at the y-intercept, down 2 to the right 1, down 2 to the right 1, down 2 to the right 1. You always go to the right. The only thing that changes is if the rise is positive, you go up to the right. If the rise is negative, you go down to the right. When you connect them, it's a negative linear function. It's going to be negative because your slope is negative. Annalise?
Where did you get the slope?
Can anyone explain that? Where'd the slope come from? Mary, where'd the slope come from? Yep, M is right here. Because any whole number always has a 1 on the bottom. Think back to chapters 1 and 2. Any whole number always has a 1 on the bottom. Well, no, I mean, not usually, because it could be y equals 1/3 x plus 2. It could be y equals -5/4 x minus 10. So no, it doesn't have to, but if it's just an integer, there's always a 1 on the bottom. Okay? Anyone else? Okay, next one. Number 2. Y equals 1/2 x minus 2. I want you to write on your paper the y-intercept as an ordered pair. And I also want you to write down the slope and draw the arrows of the way you think it goes. And then don't graph yet unless you're really confident. Well, you're okay because you're ahead of us, Charles. You ready for your quiz? Yeah, you can tell her, and then come on back. I'll put it on this desk, Jamie. Sure. Okay, Emma M., what's the y-intercept as an ordered pair?
0.
Good. 0, comma, -2. Briar, how do we graph 0, -2? Good. Down to -2. Okay, Annalise, what's the slope?
1.
Good. The rise over the run is 1/2. So Jeremy, what arrow goes next to the 1? Up. Donatus, what arrow goes next to the 2? To the right. Good, that way. Very nice, Donatus. So after we start it, 0, -2, we go up 1 to the right 2. Up 1 to the right 2. Up 1 to the right 2, if I could keep going. Anyone want to take a guess at how we get the opposite point? Sean? Good. So we go down 1 to the left 2. To get the opposite point, you make the arrows the exact opposite. So instead of up to the right, down to the left. Down to the left. Briar. Oh, yeah, definitely. Yeah. The opposite, I don't typically teach this to everyone, but it is good to know how to get the other points on the other side. It is common sense, but not everyone thinks that way. So just do the complete opposite to get over here. Questions on 2? Okay, go to number 3. What is different about number 3? What's different about number 3, Annalise?
It's not.
Good. It's not in slope-intercept form. So Justin, how do we get this into slope-intercept form? You want to get into y equals mx plus b form. So don't subtract y. You need to leave y where it is. Remember, Justin, it's y equals mx plus b. Go ahead, Justin. Good. Minus 3x on both sides. You want to keep the y where it is. So y equals, always write the x term first, negative 3x. Is it a plus 2 or a minus 2? Plus 2. So y equals negative 3x plus 2. Sean, what's the y-intercept as an ordered pair? Good, 0, 2. So when we graph 0, 2 over 0 up 2. Zach, what's the slope? Over. Good, negative 3 over 1. Adam, does the negative 3 go up or down? Good. Adam, does the 1 go right or left? Good. So once you have your 0, 2, go down 3, 1, 2, 3 to the right 1. Down 3 to the right 1. How do I find the opposite point, Annalise? Good. Up 3 to the left 1. Up 3 to the left 1, etc. You guys like this way the best so far?
Yeah.
I agree. Questions on number 3? Okay. Go ahead and try number 4 on your own, and then I want to do some harder problems with you. So go ahead and try number 4 on your own. We'll go over it. Yeah, it's off a little bit. Is that a 4 or a 14? What's this 1? Why is there a 1 in front of it? Oh, okay. Gotcha. Cross off that 1 so yeah, I gotcha. Just so it doesn't look confusing. Briar, slope-intercept form. Divide by 3. Don't forget, guys, you got to get it into slope-intercept form. Yes, so you are good with that. Yep, perfect, Emma. Let me see your. Good. Slope-intercept form. You do minus 3x on both sides, and then divide by negative 3. Okay. Nope. Did you divide everything by negative 3? Yeah. Yeah, 3 over 3 is 1. That should be a minus 4. It is? Okay. Okay. It's supposed to be sure. Yeah, you guys, picture function form. Is that a 12? No, 4. You're good. Is that a negative x? Try that again. Should not be negative. Good.
I have a question on the formula. How, it says mx plus b, but how are we really adding a slope to the y-intercept?
Adding? What do you mean by that?
Because it's mx plus b.
You're not always adding it, because if it's a minus, that means b is negative. This is just the standard form of it. It doesn't always have to be positive. This is not always positive either. That's like the slope formula. X, y2 minus y1.
Just like adding them.
Yep, and then graphing them.
Adding them to get something.
No, you're never adding them to get something. They just want you to know the equation has to be in this form for you to graph. That's the point of it. All right, some of you guys were not so good with function form. So Jeremy, what's the first thing we have to move to get this into y equals form? No, don't do that. You want to get y by itself. So what do we move first to get y by itself? Take a guess. Good. So first thing we do is minus 3x on both sides. We have negative 3y equals negative 3x plus 12. Do not leave it like that. Now what? Now what? Good. Divide every single term by negative 3. So what should the slope-intercept form equation be, Sean? Good. And just so you guys know, this equation, y equals mx plus b, it has to be in that form to graph this way. That's why we learned that it's y equals mx plus b. Okay, that's just the standard form it has to be in. You always want the x to be first. So, go ahead.
So in front of the x, it's
Yep. In front of the x, you just can't see it, there's really a 1 over 1. So the y-intercept would be 0, negative 4. The slope would be 1 over 1. So Briar, where do we start with graphing? What do we need to do first? Good. Go to 0, negative 4, go up 1 to the right 1, up 1 to the right 1. Charles, how do we get the opposite point? Yep. Good. Down 1 to the left 1, down 1 to the left 1. So yes, you could have graphed this using x and y intercepts or using a table, but I still think it's easier to put it into slope-intercept form and graph. Questions on 4? Okay. Keep your notes where they are. I want to give you guys a piece of graph paper to do a couple extra problems that are not in your notes. So keep your notes out. Keep your notes out. Get 2 more here. Keep your notes out. You can put your name at the top of this if you want, and then eventually if you want to 3-hole punch this and put it in your binder with your notes, you can. Okay, so I want you to write down number 5 on the top left graph that you have. And I want you to write down y equals 1/3 x. Adam, did you pass back the graph paper? Sorry guys, Adam's hoarding it all up here. Okay, number 5, just pass them back. Enough to fit on here. You just need one. Just need one. Y equals 1/3 x. Yeah, these ones are a little harder. Of course, I made these ones up. Okay. So number 5, did everyone write down let me give you guys a minute. Write down the equation, put a number 5, and then you might want to put y-intercept, dot, dot, slope, dot, dot. Okay, what is the y-intercept on this one? Matt? Why, Matt? Good. There's nothing here. Okay, if there's not a number there, your y-intercept is 0, 0, which means we start at the origin. Kind of nice. This is actually called a direct variation equation because y and x vary directly. So we're not going to get into that. That's more of an algebra concept. But if there's nothing here, your y-intercept is always 0, 0. Annalise?
but on y-intercept doesn't x becomes
Yep.
just 1
Times 0, which is 0. Yep. Okay, the slope, Adam, is what? Good, 1 over 3. So we would go up 1 to the right 3. It's always rise over run. Up 1 to the right 3. Up 1 to the right 3. Briar, how do I get the opposite point? Good, down 1 to the left 3. Down 1 to the left 3. Connect our points. There's our graph. So the reason I did this one is you will have a plus 0 sometimes. Questions on that one? Okay, number 6. I want you to put on your paper x equals 4. So number 6, x equals 4. And then write down y-intercept or b, and then m or slope. Okay, what is the y-intercept on this one? Briar? Nope. What's the y-intercept on this one? Charles? Nope. Y-intercept. What's the y-intercept? Emma H? Say that again. Nope. Annalise? Okay, let's start with this. What's the slope? What's the slope? Matt? Nope. Hold on. Shh. What's the slope? Donatus? Kind of, but that's not what we call it. Mary? Good. Doug, do not yell things out. The slope is undefined, okay? If the slope is undefined, what does the graph look like? This way or this way? This way. How do you graph that? Mary, how do you graph that?
Go over from where each is the
Good. So let me ask you again. What's the y-intercept? Where does that graph cross the y-axis? Charles? Nowhere. But it's not undefined. There's just not one. The slope is undefined, not the y-intercept. I mean, I guess you can kind of argue that it does kind of mean the same thing. If you have x equals a number, it's always a vertical line. Slope is always undefined. That's the example of when you have like 4 over 0, okay? There's not a y-intercept. Emma.
So does it just depend on what the next equals?
Yep. So like, for example, remember we made the table, guys? If x is always 4, y can be whatever you want. You know what I'm saying? So if x is always 4, y can be whatever you want. Okay? So think back to what we did at the beginning of the chapter, guys. When you're thinking of x equals a number, what's the graph look like? We okay on that one now? That one's a little tricky. Okay, number 7, y equals, yeah, it took some thinking. Y equals -3. But you with me? Paying attention, okay. Number 7, y equals -3. I want you to write down y-intercept, slope, and think about it for a minute before we go over it. Okay, what is the y-intercept? Jeremy? Good. Y-intercept is 0, -3. Donatus, what's the slope? Y. Do you know why? Yeah, there's no slope. Go straight across. There's no rate of change. So to graph this one, 0, -3 is right here. It goes straight across. And again, if you don't remember that, make a table. All the y values are -3. X can be whatever you want.
It's x equals.
Yep, always. And remember, y equals a number goes this way. That's why it has a 0 slope. Questions on that one? Okay, number 8, y equals 0. Number 8, y equals 0. Just kind of a weird one. Okay, y equals 0. Doug, what's the y-intercept?
0.
0 what? Good, 0, 0. It's just the origin. Okay, Alyssa, what's the slope? Good, everything's 0. Kind of boring, huh? Okay, how do we graph it? How do we graph it? Emma?
It's just
Awesome. It's on the x-axis. Yes, there are graphs and equations that will go through the axis. Okay, Annalise?
wait, how do you know it goes through the x-axis?
Because the y-intercept is 0, 0. Okay? If you make a table, y is always 0. Okay? No matter what you pick for x, y is always 0. So look, over 2 up 0, over 1 up 0, over 2 up 0. So you have points everywhere. Okay? If you're not sure, make a table. Eventually, you'll have these memorized. Jeremy?
It says it can't be over 2 down.
What could?
Over 2
I said that one, though.
up.
Oh, I got you. Either way. I always say up for some reason. Questions on that one? Okay. Let me show you this. Okay. So this is my little cool slope interactive activity. Y equals mx plus b is really what this should say. Right now I have it at m is 1.5, b is 0. Okay? I'm going to move b to be 1. What's going to happen if I move b to be 1? How is that going to move, Doug? Right, but what's going to happen to the graph is all I'm asking. If I make b 1, how's the graph going to move? up, down, left, right. Okay, up. So look, everyone watch. Moves up. Okay? So I'm going to keep B at 2. What's going to happen if I make M bigger? If I make the slope bigger, Sean, what's going to happen? Yes, kind of. Explain it to me, though. The larger the slope, the what the line? Charles. Go ahead, Charles. Yell out. Say what you just yelled out. Steeper. Okay, no yelling answers out. Okay? If I make this bigger, watch the line. See how it gets steeper? Okay? Keeps going this way, this way, this way. It's getting steeper. It was like this. Okay? It's getting steeper and steeper and steeper. The larger the slope, the steeper the hill, / the steeper the line. Okay? Donatus? Because it did say f of x. I didn't teach you that yet. I didn't teach you that yet, so I changed it to y equals. I'm going to teach you that, just not yet. I also changed this. They had this as something weird. All right, what about if I make the slope negative? What's going to happen to the line? Alyssa? It's going to flip around. So there we go. Now we have a negative line. Okay, so I just wanted you guys to see, the bigger the slope, the steeper the line. And also when it's negative, it's going to go down from left to right. Mary? Yeah. It'll just keep getting closer and closer. You can't even tell it's moving now. Oh, it won't let me go any further. This thing's not that great. Donatus? What? It doesn't go any further, though. Yeah. All right, let's do one more problem. Okay, number 9, you need to flip over your graph paper. This is not in your notes, okay? So you'll have room at the top of your graph paper. Okay, I'm going to read it. You don't have to write it down. We're going to come up with an equation from this word problem. Okay, we belong to a fitness club. Our membership fee is $30 per month. If you are a member, we have some exciting water aerobic classes. Doesn't that sound so fun? For $3 per session. Letter A, write an equation that gives the total monthly fitness club cost as a function of the number of water aerobic sessions that you attend per month. First question, what is X and what is Y? Donatus. Yep. Number of classes, water aerobic classes. What would Y be? Mary. Close. A little more specific. Annalise? Money. Yep. Mary, that was pretty close, but be more specific. It's the monthly payment, the total amount of money. Okay? Y equals mx plus b, in a second, hold on, is the equation I want you guys to use when they ask you what is the equation. Anyone want to take a guess? What would the equation be if the classes are $3 per session and we know that the fee is $30 per month? Emma M? Nope. Has to be y equals mx plus b form. Adam? Can you explain why? Good. So the key words for slope, per, each, every, rate. You're paying this every class. Why is this here? Why does this 30 not have a variable next to it? Charles? Good. Correct. But it's only 1 month. So if this represents 1 month, why does this not have a variable next to it, Mary? We're not getting into that right now. Not necessarily. Annalise. Thank you. That's all I wanted to hear. You pay this once. Whatever you pay once goes in for B. Whatever you're doing routinely on a consistent basis goes next to X. Is everyone clear on that? It's pretty easy, but I just want to make sure we all understand. Okay, letter B. Don't worry about graphing that. Letter B says, find the maximum number of sessions you can attend per month to not exceed your $60 monthly fitness budget. So $60 monthly fitness budget. How do we do this, Sean? Where does 60 go first? Back up a little bit. Good. So 60 equals 3x plus 30. Go ahead and solve for x. Remember, y is the total amount of money. Okay, x is the number of classes. If you haven't already, go ahead and solve for x. And then raise your hand once you have an answer. Be honest, do you have an answer? Alyssa, what'd you get? Good. So the maximum amount of classes is 10. Yes. No, there's only one answer for each of them. Okay. Okay, so 10 classes. Mary? Maybe. At the end of the year, maybe. Not now. Hey. Questions on this? Okay. Open up your homework packet to 8.5. Okay, you have 2 assignments. And we have like a minute or two. Practice 8.5, numbers 1 to 13 and 20. Hold on. I didn't teach you about parallel and perpendicular yet, Charles. How'd you know that? All right. Sounds good. Sorry. All right, we need a 3-year accelerated class. Okay, 1 to 13 and 20 on 8.5. Not all of them. Even though Charles disagrees with me, I really didn't teach you everything yet. Okay, so 1 to 13 and 20. And then the lemonade problem, kind of an interesting problem. That is in your homework packet 139. Okay, and there's a front and a back. So, Jeremy, you should be with me so you know what the homework is. Okay, open up your packet so you can find it. I'm holding up the lemonade problem. It looks like this. There's a front and a back. Don't come in tomorrow and tell me, oh, I didn't know there was a back. Okay? There's a front and a back. Everyone with me? I know some of you are going to come in tomorrow and tell me that. There's a front and a back to the lemonade problem. Alyssa? Yes. And then it says lemonade stand underneath it. Yep. Emma H. I need to buy more, but that's a good idea, Emma. For following directions correctly, right? Oh, good. Well, okay. We're not going to deal with that now. I'll grade them and I'll give them back. That way then we can talk. All right, guys, if you're good, we can get packed up. Good job today. Jeremy, you need to do homework and test corrections. You got it? Jeremy?